Today we're going to have an inside look at the solar grid tie microinverter. Now, these ones here just have the generic label on them, but they are made by KD. If you look at the barcode, if we can get it without the light shining on it, there is a KD number on there. I believe that the actual barcode number, the number below the barcode, is actually the serial number, because I have two of these identical, neither of them work, and they both have the last three numbers I think are different, or two numbers are different. So I think it signifies the year and model or something like that, but the best that I can tell, these are made by KD, and the model appears to be a KD-GTI-600W. So it's a 600 watt KD unit. Now, here's the board, and there's no indication, there's no number, no name on there, which is a little bit weird because KD usually, at least on their older ones, had their name and the model number stamped on it, but I know by the layout, by the trimmer pot, by the fact that they're using the blue boards, just the circuit design, the way they piggyback the fuses, and on the back side the way the bus runs to the transformers, and the circuit layout. This is a KD model, and even the transformers they use are KD GTI 1000 watt, and they use these, I believe, in all of theirs. Now, there is a 110 version of the transformer, which is a 16 volt 110 version, and they have the 16 volt 230 volt version. Now, I don't know whether this newer model is supposed to be auto sensing. I know my Greenergy Star ones are. They'll sense either 220, 240, or 110, 120 automatically and adjust the output accordingly. The reason I say that is because I thought that these were for a 220 line by mistake, but I hooked them up to one of those step up, step down transformers to apply 220 volts at the grid tie, and it made no difference. It didn't blow up, and it didn't work properly. It did exactly the same thing as it did on 110, which is the light just goes from red to green, and blinks and does that. So this is basically it. This is your 600 watt here, and what we have is your DC side here. You got two big caps, 2200 microfarad each, tied to the same bus. You got your B plus and your B negative that go to each side of the cap, and you got your three transformers. Now what they do is they ramp up the voltage. So what they do is you have your chopper circuit there, your DC MOSFETs down here. Each MOSFET drives one side of the center tap transformer, and that's all controlled by the logic on the other side of the board, which controls your oscillating frequency of the inverter. Now, it took me ages to figure all this crap out on the 1000 watt one that I worked on, because I had no idea. I'd never seen one of these before, man. But I have worked in electronics for years, so it just took some time to try to figure out what they were doing. And here's the back side. And so what happens here is this is all your logic control here. This is what controls your timing, this controls your sensing of voltage, and then you come into here, which drives your DC MOSFETs, and these are your transformers right up here. your center taps. So you got one MOSFET there, one MOSFET there, one MOSFET there, one MOSFET there. So what happens is each second one is one side of the cycle, and then it switches, and then the other side of the cycle switches on. So what you're doing is you're inverting the cycles on the transformer in unison. So this side, this side, this side, then this side, and this side. And then what they do with the output of it is they feed it in series, one into each other, to ramp up the voltage. Then it goes to some high-speed switching diodes here, which I'm not sure whether there's two common anode or two common cathode, but they have a combination of common anode and common cathode dual diodes in here, and then they feed your AC MOSFETs, and then you're coming out your AC side. If I can get this turned over and we can see here. So here's your diodes here. So you're coming off your transformers, you're coming into your diodes, and here's your AC MOSFETs here. And then your fuse, your AC fuse, and your outputs. You got optocouplers there. So basically I just don't know why the thing don't work. I don't know if they got a whole batch that they sent out, whether they're the wrong ones, whether there's a component that's not installed, because here it looks like there's a spot for some diodes that were never installed in this model. Here there's another capacitor that hasn't been installed in this model. So whether somebody just forgot to put certain parts in for a certain model or what, I don't know. I just don't like the way it's laid out. I don't like the fact that there's no number on the board to tell people which voltage it's for. You know, it's too easy to make a mistake in assembly when the only thing you got to identify it is a sticker on the cover. Now, there's only one adjustment, and I don't know what that adjustment does, and it looks like it's very close to the LED board, so maybe it's something to do with adjusting the sensing voltage or something like that. You know, I may try turning it on one of them to see if it actually makes it fire up or not, but without knowing what exactly it does, I can't recommend monkeying with it. You know, when you're dealing with voltages, you could fry the thing up. I think it might adjust your low cutout, you know, or maybe even the low-high range. It might move it slightly, because originally I think these were 14-volt cutouts, and then all of a sudden they started being 10.5s. So somehow they lowered the voltage. So what they've done, I don't know. I don't know why they don't work. I don't know if they're just the wrong ones for a 110-volt system. I wish I could get a look at the transformers of one of these that works, that somebody has working on a 110-volt system, to see if the problem is just the wrong unit or what parts are different, because I really have no idea why these don't work. But I got two of them that are exactly the same, came that way from the factory. So that's it. That's the look at this thing as far as I'm concerned. You know, stay away from them. I was impressed with their design before. The weak part of them was always the AC. These wires would break, those wires would break. But you know, now after getting these defective ones, I can't recommend them at all. You know, they were a fairly simple, fairly rugged inverter. At least a 1,000-watt one was that I worked on, after it driving me nuts for probably 2 months trying to map out the circuit design with no schematics and figure out where the problems were. Half of the problems were inside here, right? Because it would work, and then I'd put it back into the case and it would stop working. So half of the problems I was finding were inside here. The wires had broke off inside the heat shrink tubing, and when I connected up to the unit, it wouldn't turn on. It would just stay on fault. So then I'd take it apart and it would work. So it was just driving me nuts anyway. So anyhow, that's a look at that. So if it was any help to you trying to identify a board or trying to identify a problem, then good. If you have one of these that you've blown up and you need any information, just post a comment. I'll do what I can to try and find out anything I can for you. Right now I don't have the value for all the MOSFETs and diodes and stuff like that, but if needed, just post it in the comments section and I'll try to get that information up there for anybody that might need it.